Hello everyone. In previous class we were discussing about dehydration of alcohols. We studied how dehydration of alcohols takes place. Let us learn mechanism of dehydration of alcohols. On dehydration of alcohols we will get alkenes, right? In dehydration of alcohols, in presence of some acids, protic acids, then formation of alkenes takes place, right? So primary alcohols, secondary alcohols, tertiary alcohols we have studied. Primary alcohols will undergo dehydration at 443 Kelvin and in presence of concentrated sulfuric acid, and secondary alcohol will undergo dehydration at 440 Kelvin and around 85% of phosphoric acid, and a tertiary alcohol will undergo dehydration reaction at 358 Kelvin and at about 20% of phosphoric acid. Let us learn the mechanism of this reaction. The first step is step 1, protonation of alcohol. So source of proton is here acids, mineral acids, right? CH3, CH2, OH, ethanol, right? Ethanol on reaction with proton, right? Proton here, lone pairs, then what will get here, it will undergo reversible reaction and is fastest step will get CH, H, and here CH2, ethanol, CH2, and here protonated ethane oxonium ion, right? We will get protonated compound. In step 2, what happens is carbocation formation takes place. Formation of carbocation, right? I will take that compound CH2 and protonated alcoholic group. Now see properly, this is protonated and oxygen is electronegative and electron deficient, and OH is not good leaving group, protonated one is good leaving group, and it takes this electron and will leave. Then what will get? The slowest step and rate determining step. Okay. Next, CH, and here CH2, and here formation of carbocation takes place. Here it eliminates and will get a carbocation, carbon containing positive charge, carbocation, right? In third step, in step 3, very important reaction as well as a mechanism. Step 3, elimination of hydrogen takes place. That is formation of alkene. by the removal of a hydrogen, right? That is CH3 single bond CH and H. This is carbocation, right? Next step, what happens is this hydrogen eliminates, right? This electron diffusion shifts over here and formation of alkene takes place. Am I clear? Now formation of alkene CH2 and CH2 here double bond, right? This is about mechanism of a formation of alkene by in the presence of acid. Okay, in the presence of acid. So acid on reaction with the hydrogen, dehydration takes place, and next in presence of acid, dehydration takes place and formation of alkene. First step is protonation of alcohol, second step is formation of carbocation, and last step is formation of alkene by the elimination of a proton. Now you can come to know why tertiary alcohol will react easily, or it will react even in the mild condition. Why? Because see here, carbocation formation takes place. As we know, carbocations are more stable compared to tertiary carbocations are more stable compared to secondary carbocation and primary carbocation. Hence, reaction in tertiary alcohols will take place in a milder condition. Hope it is clear for you now, right? Here tertiary carbocation is more stable, hence it will undergo reaction easily. Primary is not much stable, right? You can come to know this by this mechanism. This mechanism is very, very important, reaction as well as mechanism. Let us move to the next reaction, that is oxidation reaction. We already studied reduction reaction, where we have studied reduction of aldehydes or ketones or carboxylic acid to form alcohols. In preparation, we have studied reduction. Now in reactions, fourth one is oxidation. See, oxidation. See, oxidation is addition of oxygen, reduction is removal of hydrogen, as we know. So in oxidation reaction, we are going to remove hydrogen, but in reduction reaction, what happens? We are going to add hydrogen. So what we have discussed in previous class, reduction reaction, right? Aldehyde on reduction, on oxidation, I already said. On oxidation, I'll start from alcohol on oxidation, aldehyde or ketone on oxidation, we will get acids, right? And we already studied reduction reaction. Acid reduction gives aldehyde or ketones, aldehydes or ketone reaction, reduction will give alcohols. This we studied in preparative method, right? Reduction reactions, right? In chemical reactions, we are going to study this oxidation of alcohols to form aldehydes or ketones, which on oxidation will get acids. So let us discuss one by one oxidation reaction involved in aldehydes and ketones. So oxidation of alcohols involved in the formation of carbon oxygen bond and breakage of CH and OH bond. I will take one example. COH. I'll write like this, COH, and here it is Yeah, one aldehyde, right? So in oxidation, here formation of carbon oxygen bond takes place. Formation of this one, carbon oxygen bond formation takes place here. This bond formation and breaking of which bond? OH and one more CH bond takes place. During oxidation, what happens? Formation of carbon oxygen bond and breaking of OH and CH bond takes place. I will explain with the example. As I already said, alcohol on oxidation will form aldehydes, right? Or ketones or carboxylic acid. What is the functional group there? C double bond O, carbonyl. Hence, formation of CO bond takes place. One more bond, right here. One more bond and breaking of these bonds takes place. I will explain by taking examples. Now, one more thing, in reduction reaction, I have already explained that aldehydes or ketones, aldehydes on reduction leads to the formation of primary alcohol, and ketones on reduction will result in the formation of a secondary alcohol. This you already know. Now, what about oxidation? Primary alcohol on oxidation gives aldehyde. Secondary alcohol on oxidation gives ketones. So, I can easily predict the formation of a product. Aldehydes on oxidation gives primary alcohols and ketones on oxidation gives primary alcohols on oxidation gives aldehydes and secondary alcohols on oxidation gives ketones. Let us see by taking a few examples. RCH2OH, here it is primary alcohol, which on oxidation in presence of chromium trioxide. What happens? Chromium trioxide, we will get CrO3, right? It is oxidizing agent. We will get R, instead of RCH2OH will gives RCHO, aldehyde. Primary alcohol will result in the formation of aldehyde. Don't get confused. Here one R is there. Just write R group. And oxidation means a removal of hydrogen, right? 2 hydrogens are got removed, right? Total 3 hydrogens are there. 2 hydrogens will remove. Then results in the formation of alcohol. Okay. In presence of strong oxidizing agents like potassium permanganate, KMnO4, alcohols, primary alcohols directly give carboxylic acids in presence of strong oxidizing agents. Without the formation of intermediate aldehyde, RCHO aldehyde directly forms a carboxylic acid. Okay, some milder oxidizing agent leads to the formation of aldehyde. This can be further oxidized into carboxylic acids. Now, what about secondary alcohol? RCHOH and right, secondary alcohol will leads to the formation of in presence of CrO3. As I said, RCHOH R dash. This is secondary alcohol. We will get R C double bond O R dash ketones. Just instead of CH, write C double bond carbonyl compound. Here also instead of CH2, write RCHO. That is R CH2 is there. There C double bond O H aldehyde. Right? This is about preparation of aldehydes and ketones by using oxidizing agent like chromium trioxide. And if we take primary alcohol, we'll get aldehyde. Secondary alcohol will leads to the formation of a ketone. So, better reagent for the oxidation of primary alcohol to yield good product to the formation of a good yield, we will use pyridinium chlorochromate, that is PCC. Okay, pyridinium chlorochromate. Okay, pyridinium chlorochromate is one of the complex of chromium trioxide and pyridine and HCl. Its structure is pyridinium chlorochromate, so O minus, and here it is Cl, and one more is your pyridine as I already said. Okay, excess I'll write here plus. Okay, it is a complex. Pyridinium chlorochromate is a complex which is acts as a good oxidizing agent. By using this, we will get a very good yield. Short form is PCC, don't forget. So, primary alcohol, if you take CH3, any primary alcohol, CH3, CH2, CH double bond CH, this kind of compound also this kind of compound can be converted into what? Converted into respective carbonyl compound. The product is CH3, CH2, CH double bond CH, CH2, and here C double bond O H aldehyde formation takes place by using pyridinium chlorochromate. Right? Pyridinium chlorochromate is nothing but is a complex mixture of pyridine and chromium trioxide in HCl. Right? It's about oxidation. Then tertiary alcohol will not undergo oxidation reaction easily. We already studied primary and secondary alcohols. Primary alcohols will give aldehyde, secondary will give ketone. Tertiary will not undergo oxidation reaction easily, but on oxidation in presence of good condition and with high temperature and good oxidizing agent like potassium permanganate is very good oxidizing agent. Then formation of carboxylic acids takes place. So various carbon chain breaks. This carbon chain breaks and formation of carboxylic acids takes place, but only in presence of strong oxidizing agent. Right? Next, primary alcohols on reaction with the copper at 573 Kelvin, then formation of aldehyde takes place. That is RCH2OH alcohol. What is this? Primary alcohol in presence of copper at 573 Kelvin. Then oxidation takes place. Is primary. Why? Because it is directly attached to only one carbon atom. Then what we will get? R instead of CH2 we'll get aldehyde, RC double bond O H. Now what about secondary alcohol? RC, I'll take it as R dash, and here H and OH in presence of copper at 573 Kelvin. See, secondary alcohol condition is same. Then what we will get? As I said, we will get a ketone, right? RC double bond O R dash. Clear? And if we take what is this? Tertiary alcohol, R dash, R double dash I took, and we will end up with the formation of alkene. We will not get the product that is aldehydes or ketones. To write, we will get a alkene. Here I will write one example so that I can easily write the structure of alkene for tertiary. Okay, for this also, or else for all I will write the example. First one is RCH2OH. I will take CH3, CH2, OH. Condition is same, copper 573 Kelvin. What we will get? CH3, C double bond O, H aldehyde. Second one is here, that is CH3, secondary CH3. You are getting CH3, one hydrogen, and here OH in presence of copper at 573 Kelvin. What will get? Ketones, right? CH3, C double bond O, CH3, right? We will get ketone. Now, what about tertiary alcohol? CH3, CH3, OH in presence of copper at 573 Kelvin. We will get, as I said, alkene formation takes place. See, CH3, C. Here it becomes a double bond. Elimination of water takes place. I have explained this kind of reaction before. Then what we will get? CH3, alkene formation C. Here it is CH3, double bond CH2. Alkene formation takes place. This is about a reaction of alcohols, that is oxidation reaction of alcohols. So, oxidation of alcohols leads to the formation of primary aldehyde, secondary ketone, and tertiary will not easily reacts. If it reacts, will give alkenes, or at a very in presence of very good condition, or in presence of good oxidizing agent, and at elevated temperature it will form some carboxylic acid. Some chain breaks and a different carboxylic acid formation takes place. This is about oxidation. Be concentrate properly. Oxidation, reduction, just opposite to each other. So that once if you learn reduction reaction, you can easily write oxidation reactions. Okay, just remember reagents, conditions and all. Next is commercially important alcohols. Some important alcohols in that we are going to learn about methanol and ethanol. Some commercially important alcohols. Okay, commercially important alcohols. In that first one is methanol. Formula CH3 OH. It is also called wood spirit. Okay. So earlier days, this methanol was preparing by destructive oxidation of wood. Hence the name wood spirit. Okay. Earlier days, this methanol was prepared by the destructive distillation of wood. Hence the name is wood spirit. Nowadays they are preparing this methanol by the reaction with the carbon monoxide and hydrogen. Carbon monoxide and hydrogen on reaction with in the presence of zinc oxide and Cr2O3 at 200 to 300 atmospheric pressure will leads to the formation of methanol, and temperature is 573 to 673 Kelvin. That is earlier days destructive yeah. It's correct. Methanol is destructive. Sorry. It is prepared by carbon monoxide on reaction with the hydrogen will get a CH3OH. Sorry. Carbon monoxide on reaction with hydrogen, we will get a methanol in presence of Cr2O3 and zinc oxide at 200 to 300 atmospheric pressure. Okay, 200 to 300 atmospheric pressure, we will get a methanol. So, properties of methanol. Properties of methanol. Methanol is colorless liquid. Okay, as we know, methanol is a colorless liquid with boiling point 337 Kelvin. Okay, boiling point is 337 Kelvin, and ingestion of methanol. Okay, if a small amount, if it is injected, which leads to blindness. Okay, it leads to blindness, and excess. If you inject to your body, if it is injected to your body, if it is excess, it leads to death. It is fatal. Okay, so this is about methanol. Methanol is a formula CH3O2. It's also called wood spirit. Why? Because it is it was preparing by the destructive distillation of wood. Okay, it's earlier days, correct? Nowadays they are preparing by using carbon monoxide and by using hydrogen at 200 to 300 atmospheric pressure. And properties: colorless liquid, 370 Kelvin is its boiling point, and it is very, very, very poisonous, and it leads to blindness as well as death. This is about one of the commercially important alcohol, that is methanol. Thank you.